Thank you very much, Igor. Wow, you guys are a patient audience. I see the seats still full. Amazing. I didn't expect half of you people to be here. Anyways, so I was talking about streaming aggregation, how watermarks actually allow you to configure how much late data you want to consider versus how much resources you're willing to pay for. And those semantics are clearly separated out from the actual query semantics of what the result would be. Taking out from there, so these are streaming aggregations. I do not know what is going with the lights. Somebody needs to run a streaming application on that and alert someone with less than a second latency. Okay, somebody got alerted. Yes. Anyways, so streaming aggregation automatically does stateful stuff without you realizing it. But for a lot of applications, you may want to do far more complicated stateful stuff. And to enable that, we have in 2.2 added something called map groups with state. Now, this is something for people who have actually tried dstreams. If you know about update state by key or map with state, this is a beefed up version of that. This is those two on steroids. So, but this is exactly does what that does. So basically, for those who are not familiar with those map with state and update state by key, what it does is that it allows you to keep arbitrary data structure as state. And you can do arbitrary updates on the data structure as new data comes in. Actually, I will explain this with an actual clear application in the later part of my slide, but what you need to remember is that if you have arbitrary stateful stuff like, for example, sessionization, where you want to monitor a particular user session or somebody's playing a video, you want to understand what is happening as part of that video session, this is the thing to use, where you can keep all the session metrics and the session metadata as part of the custom user-defined state, and as there are events from that session coming in, people logging in, logging out, or people pausing the video, unpausing the video, those updates can update that session state. I'll explain this with a more concrete example later. But we support this, as of 2.2, we support this in only Scala and Java. So other interesting operations that I will not go into too much detail is something called streaming duplication, where it's, again, very transparent dropping of duplicates. So if you know that your upstream pipeline writing into Kafka or writing into some other places, your devices can write duplicate data, but each of your data item has a unique ID, then you can transparently drop those duplicate items by just saying drop duplicates, your unique identifier. And underneath, what the system would do is that maintain the necessary state of the past received data and their unique IDs, and by using that to dedupe all the future records. Now again, in this case, you can imagine that the size of the state can grow infinitely as more data, more unique records comes into the system. So you can, again, use watermarks here to limit how much state you can keep. For example, if you know that your duplicated data is going to come within, let's say, 1 hour, and there's no chance of duplicate data after an hour, then you can specify your watermark as 1 hour. And the system will automatically maintain all the unique records in the last 1 hour as state and automatically clean that up and stuff. The other thing I didn't go through because kind of it's so natural is that you can very easily join streaming data with batch data. And this can be used to augment your data. For example, you have device data events coming in. You can basically, you have another table where you have device-specific additional information like device-specific thresholds and stuff. You can join that batch data with your streaming events to kind of augment the events and write out more information as an ETL step or doing more alerting. Again, I'll give a actually more interesting example of that later. And what we don't have right out of the box yet is stream joins. We are working to add it as soon as possible, but with the addition of map groups with state, you can build your own arbitrary stream joins because map group state is like the assembly language of writing stateful stuff. You can keep arbitrary state, which means you can do arbitrary windows, arbitrary joining windows, and merge two different streams into one, and then update the state. So you can hand code your own custom complex stream joins using map groups with state. More direct support of directly out of the box X join Y on this column within last 1 hour of data. That is going to come soon. So these were basically a sneak peek into some of the nuts and bolts, some of the Lego-like building blocks of the API of structured streaming. Let's actually see how all of these APIs actually come together into building a larger end-to-end continuous application, which combines all different kinds of processing. And the best example that I can think of is essentially our own metrics processing pipeline in Databricks. So we are a cloud company. We manage Spark clusters on behalf of our customers. So that means that we have tons of clusters running in the cloud at any point of time that needs to be monitored, that needs to be, that we need to make sure whether they're running properly, whether any of them is going down, if any one of them is behaving in an anomalous manner. So which means that we have to collect all the streaming metrics and first of all, clean them, normalize them, store them in a way that can be used in future for more complex analytics, essentially ETL. We have to build live dashboards to see what is going on right now. Are there any anomalous behaviors and not? We have to write application where we need to be alerted when something does go wrong. Obviously, people are not going to continuously stare at the dashboard, so someone needs to email me or buzz my pager duty. Please don't. When something do go wrong. And when things do go wrong, I have to actually start digging deeper. Why is it behaving weird? I mean, look at more logs and stuff, other kinds of metrics, join different metrics. And so that means I have to analyze the data in an ad hoc manner. So all of these is kind of part of our continuous application of processing metrics at Databricks. Now, while we were building this out, we realized that doing this in a purely streaming manner is actually difficult. And because if we write all the data out to Kafka and we just rely on the Kafka as a streaming storage platform and build a pure streaming system, then we are limited by different ways. For example, in Kafka, typically you keep the data around for 7 days, maybe a couple of weeks, but not for a long time, not for years. That is not what Kafka is generally used for because of the prohibitive cost of putting data inside it and getting data out of it. You want something that is more cheap, like S3 or Glacier or things like that, where you can keep data in a much more structured, compressed form. And obviously, for ad hoc queries, when I have to actually go and dig deeper, it's hard for me to actually stream all the data of the last 1 hour where I'm only care about only some of the columns in the data and not the rest of the columns. So it is not very inefficient to read all the data from Kafka. So you can't do things like filter, push down, etc. into Kafka, which you can do in Parquet, to read only the data that I need to read. And then for someone like a business analytics person who actually going to build dashboards around it for CEOs, CTOs, other C-level people, they are not going to write Kafka queries, right? They're going to more likely to write SQL queries. So you need to be able to build something on which you can write SQL queries and it gets results within seconds for the less tech-savvy users. So we ended up building this elaborate pipeline, all using Spark and mostly using structured streaming. And I'm going to walk through actually all of these steps to see to show you how easy it is to actually envision this sort of a pipeline. And I truly believe that some of your streaming pipeline that you want to build will essentially pattern match into this. And so I hope I can convince you that the stuff that we did and to build our pipeline, you can do exactly the same set of stuff to solve your problems as well. So the step one that we started out doing is basically the streaming ETL. I've already went into details to talk about it in the first part of my talk. For those who were not here for the first part, please do take a look at the slides. But a very quick reintroducing is that we create a data frame from Kafka data, which reads the raw logs from all our services. And then we parse the JSON using built-in functions, and we join it with our additional table, which has more information about our customers to actually augment the data. And then finally, this augmented logs, we actually use that in multiple ways. And that is another cool thing that we actually realized while building a truly complex application, is that a huge benefit of this API is that you can create a bunch of these data frames and reuse them. Because as soon as you're creating data frames, you are not exactly starting to process. You're just setting up the computation, setting up the query that this is what I want to compute, not actually starting to process the data. So you can create this bunch of data frames, you can register them with table names and build a library around it, and then give it to your different sub-organizations and stuff that here, use this data frame or use this table. You can actually start getting the raw data out of it within seconds. You can get either the raw data, or here is the already pre-augmented data, here is already the clean data right out of it. All you have to do is just import this library and just use this table. Then you can start writing SQL, DataFrame, Python, Scala on top of that library. So this is another advantage we realized while we were writing big application, that this is a very good tip to use for building applications on structured streaming. So now that we've augmented it, we want to first step streaming ETL, we want to write it out to Parquet. And one of the cool tricks we use is that since we don't want to create a bunch of small files, what we do is that we trigger every minute and repartition the whole data to create only one file per minute. And this is okay because our latency requirements for this is typically roughly on the scale of minutes, because the way we have built our system is that we don't care about within seconds right now, we care about within a minute. We have other requirements which goes into seconds. I'm going to go into that very soon. So, so within 1 minute latency, we can write it out to Parquet. And then once it is out into Parquet, we can do much more complex processing. As I've already said, for example, we run our own dashboards on the Parquet itself. And so as data is getting written out to Parquet, we run another structured streaming query on that Parquet table to kind of get all the updates in Parquet and start and further process them into do complex analytics and show it on the dashboard and multiple dashboards. So, and that's another advantage of having it on Parquet on S3, that since S3 is storage scales automatically as you read from it, I can run a lot of multiple parallel queries out of it, and it just scales horizontally. That is something it's hard to do with many other systems, making it scale horizontally. So a lot of those scaling problems is taken care of by this setup. Anyways, so we build a bunch of dashboards out of this, and some of the dashboards require minute-level latency. We want it to update every minute because we care about what happened in the last minute. Some of them we don't care about latency that much. It's okay to update every hour because we are windowing by hours and stuff, the number of clusters active every hour and things like that. And that allows us, because in structured streaming you can specify the trigger interval, it allows us to configure based on our latency requirements how much resources to give it and how long based on what requirements we have. So for example, if a dashboard can update every hour, we don't run the cluster throughout the hour. We just basically, we can configure it in such a way that there's a hourly job that starts up a cluster, updates the dashboards, and shuts down. But for queries that require minute level, the cluster is always running, the dashboard is continuously updated. It's completely configurable without actually having to change the code. Because your query stays exactly the same, your query semantics stay exactly the same, just your triggering interval needs to change, and you can do it based on your application requirements. Then the other thing we do is basically take the raw fire hose of logs and split it into multiple thinner streams so that other microservices downstream can do different sort of stuff like alerting and stuff. So for example, one clear case is that we take the heartbeats from our Spark cluster and actually stream it to a different topic which has a much lower data volume, and therefore other downstream alerting services can read just the necessary cluster heartbeat events and do more stuff. And here we need it to be low latency because we want to do it for alerting. So here because it's just reading from Kafka and writing to Kafka, it can be very fast within hundreds of milliseconds. And as if you have seen Michael's demo in the morning, we are actually trying to push the boundary further to make even faster alerting by lowering the latency to 10 millisecond, 1 millisecond using our new continuous processing initiative. So now that we have these topics in Kafka, what we can write is we can very easily write simple alerts that triggers within 100 milliseconds. For example, let's say if the load of a cluster is beyond a certain threshold, we know that this is going to be a problem. For example, then I can write a custom sink, a custom for each operation, which essentially pings my or somebody else's pager duty directly, or notifies email and stuff. So again, you can integrate custom sinks into it and write to custom data sinks. And for more complicated alerts, we have this, again, we go back to the map groups with state and flat map groups with state that I talked about, where for these complex alerts, you need more complex stateful streaming logic. For example, we have observed that if I haven't received a heartbeat from a cluster in a while, something might be going wrong. Or if I've received 5 errors in a row from a particular cluster, again, something might be going wrong. So that is essentially kind of like a sessionization, that for each cluster, I want to maintain the most up-to-date state, that what is the state of the cluster, how many errors, consecutive errors have I received, or how many errors in the last 1 hour. So that's very custom sessionization logic. So that, again, we can express in the form of flat map groups with state, with the session state being the cluster status. And there we have automatic support for timeouts, that if a particular session or particular cluster did not receive any data over the last 1 minute, something might be going wrong. You may want to issue an alert, or maybe wait for another couple of minutes. All of this custom logic can be implemented using this. And here we typically, because you have to wait for the data, the cluster to kind of be non-responsive or something for a while, I mean, the latency requirements is not in the order of milliseconds. The latency is in the order of tens of seconds, often minutes. So again, the latency requirements are less for obvious application level reasons. And then if we actually see some cluster is misbehaving, then we have our ETL'd Parquet logs up to the last minute to do further analysis. For example, there might be some errors in our Log4j log, so we actually go in and start writing SQL queries, what happened in the last 1 hour, how many warn level or error level logs is there in the last 1 hour. If there is too much, we'll have to dig deeper and further. But the cool thing here is that if you write the SQL query in this way, that Parquet dot, here is the path to the Parquet file, then every time you run that query, it will always pick up the latest file. So that's another trick that is worth knowing, that if you want to run SQL queries directly on the latest data, you have to write it in this neat way. So anyways, this was a very elaborate description of all the stuff we do for our metric processing. But the cool thing is that we can do all of this in a highly efficient manner because of the power of the SQL engine, that we are processing right now more than 14 billion records per hour with just 10 nodes, and with all of this thing happening inside that. And so we are able to meet very diverse latency requirements for different aspects of our continuous application with as efficiently as possible. Anyways, hopefully you can pattern match some of your streaming applications on this and understand that, yes, maybe your application can be done in the same way and has similar latency requirements, and so perfectly fits in the same way. We write in more detail about all these different stuff in our blog posts. Well, first of all, there's the structure streaming programming guide that has a lot of the nuts and bolts on these our operations. But we do a lot more deep dives in our blog posts, and so stay tuned. There's already almost 5-6 of them out there, and we'll keep adding them at least one or two blog posts on structure streaming every month. Anyways, all this cool stuff, you can try it out on Databricks right now, on the Databricks Runtime 3.0, which has the release candidate of Apache Spark 2.2. So you can go ahead and try all of this right now. And that's it for today. Whoa, I'm tired.
All right, we have 10 minutes for questions.
So you mentioned that there's the new map groups with state that's replacing update state by key and map with state. Mm-hmm. So one of the problems that we've encountered with those previous APIs is when you get into large intervals and large amounts of data, say 24 hours and a couple terabytes of stuff that actually has to be aggregated over, it starts to break down and no longer be performant or scale. Is this more performant now with the new streaming API?
So the current implementation of map groups with state, the way it is a bare bones implementation. It scales to a certain level, but the scale you're talking about, you probably have to scale out a lot more to reach that level, but it'll work fine. But we are working towards actually improving the efficiency of it, and stay tuned on our work, our blog post, and we'll definitely come up with something. But yes, we are aware of those very large state workloads, and we definitely want to increase the efficiency of processing them with lesser resources.
Hi, here. I'm just wondering about the exactly once semantic that you mentioned about with the checkpoint, you can reach exactly once. How did you do that? I don't quite understand. If you don't save the checkpoint with your data, how can you reach exactly once semantic? There's actually basically impossible.
Sorry, could you repeat the question? So the way I got it.
You mentioned about the exactly one semantic that you can reach. And also you mentioned about the checkpointing can guarantee that. But from the API I see that you provide, you actually provide the checkpoint locations different from the sink, whereas you actually output the data.
Yes.
So which means that the saving both actually is not in the transactional action. How can you provide that actually as exactly once?
Because you can, so there are two kinds of checkpointing going on. One is the metadata of what offsets have been read in which batch, and what is being written out. So the way I actually didn't have the detailed slides on that. The way it works is that before we run a batch, we actually write to our write-ahead, our offsets write-ahead log that this batch will process this range of data. And then when we write the output to the sink, our sinks are designed to be idempotent. So if a batch is re-executed or even partially re-executed, our sinks will handle those re-executions and output it once and only once. And because the batch is a deterministic range of data. The output will always be deterministic, and it will be at the partition level written only once.
Which means the stateful job actually you still cannot reach exactly once.
No, we can, because everything is deterministic. So if you start with the exact same version of the state and the exact same range of data as input, then you get exactly the same output. So we internally manage the state version as well. So the state is also co-versioned with the input. Does that make sense?
Yeah, yeah, okay. Thanks.
These are magic that you don't have to worry about. It's taken care of by the system.
I have a quick question here.
Yes.
If you have got sensitive information, can you do encryption or tokenization, surrogate keys, anything on the fly?
You can do it at the application level. So basically, if you have like a SQL function that kind of encrypts your column.
You mean to say you can implement security at the application level, not
Yes.
at the source?
Okay, separating, let me start from the basics. Spark has support for encryption, on-the-wire encryption, and a lot of stuff. For batch queries, we have, in Databricks, we have direct support for very fine-grained ACLs at the column and row level. But as of now, with structured streaming, with the stateful stuff, we do not have that support right now for the intermediate stuff. So in the state, if you want to do something that is encryption, like for example, if you want to encrypt the in-memory state and stuff like that, you have to do it at the application level. Okay. But for other kind of stuff, like plain and simple non-stateful stuff, there's a lot of support out there already. So
what you're saying is, which is a traditional way, we apply security at each of the application levels, multiple levels.
Yes, yes. And so, for example, the shuffle data between the workers, those can be encrypted. All of that support is already there in Spark.
Okay, another quick question. Your name is Tathagata. It's a Buddha's
Yes.
name. In Sanskrit, it means wanderer or streaming. Is it deterministic?
Well, as far as I knew, the name of my name was one who has come from above. But this is a new, interesting interpretation. I like it. I approve. I'm going to use that next time.
I've got two questions. Thank you
Yes.
for all the information. First is regarding the watermarking. You said that if the data is coming late, we can identify whatever the windows we specify when doing the streaming. What if my data is not late but early? If the wrong data is coming and then the event...
Hold on. I am having trouble actually hearing because of the weird echoing. So how about this? I am still available here. Let's finish the session right here. There is no other session after this, so this room is available. So how about I answer questions down there as opposed to here with a bad loudspeaker.
All right.
Bad acoustic.
Thank you, TD. Let's give him another round of applause.
Thank you very much, guys. You are a wonderfully patient crowd.